this video, we're going to learn about event-controlled while loops. Event-controlled while loops are used anytime you want to repeat an action an unknown number of times. In this way, an event-controlled while loop is more flexible than a count-controlled while loop, which should only be used whenever you want to execute a sequence of instructions a specific number of times. The event-controlled while loop allows for cases where you might not know how many times you want to repeat something initially, but during the execution of the loop, it becomes clear when the loop should terminate. Much like a count-controlled while loop, an event-controlled while loop has a series of standard steps. The first step is always to initialize the value of the loop control variable. That means to set it to a predetermined starting point. That might happen either through an assignment statement, or through calculation of an expression, or from reading a value from standard input or a file. Any of those values can be used as your initial value for a variable. When you're ready to repeat your sequence of instructions, you'll need to include a Boolean expression along with the reserved word while. If the condition evaluates to true, then Java will execute the body of the loop. That's all the statements that are inside the curly brackets, delimiting the loop's instructions. Within the body of the loop, it's important to alter the value of the loop control variables when appropriate. You want to make sure that eventually the loop condition will become false, which will terminate the loop. If you don't update the value of your loop control variables in the body of the loop, then your loop condition will always remain true, and your loop will be infinite, meaning that it never terminates. So visually, the instructions of the event-controlled while loop operate like this. The loop control variables are initialized. Then the program encounters the while instruction where it evaluates the loop condition, which could either be true or false. If the loop condition is true, the loop body will execute. And again, it's important that that loop body contain an instruction that updates the value of the loop control variable or variables so that eventually that value becomes false. After the loop body executes, you always go back and evaluate the loop condition again to determine if the new value of the loop condition is true or false. If it's true, you continue to repeat the loop body as many times as is needed until the loop condition becomes false, at which time you continue on with the rest of the program. Let's look at a small example. In this program, we're receiving input from the user until a particular condition is met. So we're going to read in some values that represent temperatures, and we're going to continue to read in temperature values until a Boolean expression is safe becomes equal to false. So my loop control variable in this case is that value is safe. I want to continue to read in temperature values while is safe is true, and I want to stop reading temperature values when is safe becomes false. So I'm going to initialize my variable is safe to be true so that I execute the loop body at least once. I'll also need to have a variable to store my temperature value. Now I said I want to repeat reading in temperature values as long as the variable is safe is equal to true. So I set up that as my loop control expression. I'm using curly brackets to delimit all of the statements inside my loop body. That's all of the statements that are indented here. Remember, Java doesn't really care about the indentation, but it does make your code more readable if you use consistent indentation. IntelliJ and Replit will both automatically indent for you, so you don't have to think too hard about the proper indentation. If you ever get code that doesn't seem to be indented properly, maybe because you have a syntax error or forgot a curly bracket or something like that, you can always use the code refactor code option within the menu. You go to the code menu in IntelliJ, and then about halfway down that menu, there is an option that says reformat code. And when you click that, it will automatically indent everything perfectly so that you'll have good style. Let's look at the instructions inside our loop body. First thing we're doing is reading in a new temperature value. That was the main purpose of our loop, was to read in these temperature values. And then we check to see if the temperature is very high. If the temperature is more than 120, then we update the value of our loop control variable is safe and make it equal to false. Maybe that's some sort of error condition. Oh, I just saw a typo down here. This end if temperature is bigger than 120, that should be a comment. That's supposed to be the comment for the closing curly bracket for this if statement. So you want to add that in there. So this if statement, that's my update step for the loop control variable. Whenever the temperature is bigger than 120, then I'm going to update the value of my loop control variable is safe so that it is set to false. In all other cases, when the temperature is not bigger than 120, then I'm going to print out the temperature reading is safe. And in these cases, I'm going to continue looping. Let's type this program into IntelliJ, and then we can test it out with some input to see its operation. I'm going to fire up IntelliJ, move it over so I can see my code that I'm copying. And remember, it's always a great idea for you to copy in the code as well and play around with it a little bit. It's great practice just in terms of formatting and entering a good Java program. And it also allows you to experiment with the code so you can see how it works. Copying all of my logical instructions here. Oh, and when I used the std in here, see how it highlights it as red and says it cannot locate a local variable called std in? That's because in the example in the notes, I omitted the declaration of the scanner just to save space. I do that a lot in the notes. So just be aware of that when anytime that you're typing in a program, you may need to add in a scanner or something like that in order to make your program work well. All right, so now I have my scanner in there and my call to the next int method is now not red. So I feel good about that. I'm gonna check to see if my temperature is bigger than 120, then set is safe to be false. And I spelled this wrong. And then I have my else down here where I'm going to print an error message if it's a good temperature reading. The end of my while. All right, super duper. All right, so let's run our program and test it out a little bit. My program's compiling, and now it's waiting for me to give input. Remember, we put in our call to the next int scanner method. We didn't include a input prompt in this program. You could go ahead and add that in if you wanted to. So I'll add one something like print line, enter a temperature value to determine if it's safe. Awesome. Let's try that out. I'm rerunning. Whoops, semicolon. Cool. So now it's running and asks me to enter a temperature value. Let's say it's 90 degrees. And it tells me the temperature safe. Let's think about whether that makes sense with our code that we have here. So we're creating this Boolean variable is safe. It currently has the value true. And then we come down and ask the person to enter a temperature value, check to see if is safe is true. And it has not changed yet, so that's true. We're going to execute all the statements in the body of the loop. So we're going to read in the temperature value. So that's where it reads in the 90 as the temperature. Then it checks to see if 90 is bigger than 120. And it is not. So it's going to go to this else and print the temperature is safe. And now it's back up here checking to see is safe true. It still is. So it's waiting for me to enter another temperature value. We can do that. So I put in 100, and again, it says it's safe. So it's reading the new temperature value, that's 100, checking to see is 100 bigger than 120. It is not, so it's going to do the else and print out temperature is safe. That was a little bit confusing in our output because it didn't prompt us for that second input value. Think about how we could modify this program to make it more clear that every time through the loop, we want the user to enter a new temperature. We update that. One way we could update that is by moving our input prompt down here inside the loop body so that it's repeated, so that it's part of the instructions that are repeated over and over in our program. Let's see how that changes the execution. I'm going to enter a 90, it tells me it's safe. Now it tells me before I need to enter the next value, it prompts me to enter that new value to determine if it's safe. I'm going to enter 100. Again, that's safe. Let's enter something that's bigger than 120. Let's do 130. Once I enter a value that's not safe, that's going to update the value of is safe inside my loop body. Then when my loop control is tested again, the condition will be false, which causes the program to continue on with the statements below the loop. In this case, it just terminates the program. Just like we could with the count control loops, we can also use the debugger for an event controlled loop. I'm going to set a breakpoint here on the first line of my while loop, and then I can use the debugger by clicking on the little bug button. Remember that like starts running my program, it'll run it until it hits that breakpoint. Alrighty, so I'm running my program and I'm going to, it ran until it reached the breakpoint on line 8. And now it's evaluating my while loop condition. I want to step into the while loop. So I'm going to press the down arrow. Now I'm getting ready to execute the input prompt. And then I'm going to read in the input. It's waiting for me to type information into the console window. I'm going to type in 90 as my first temperature value. You can see it comes up here. It shows that my temperature value is now 90. And I'm going to keep stepping through the code line by line. So because the temperature value is 90, it made my if condition false. So it comes down here and it's executing the body of the else. It's going to print out my temperature statement. Sure enough, it prints the temperature safe. Now it's evaluating the value of is safe and checking to see if it's true. And of course it is. I'm going to step into the loop again. Now I'm getting ready to execute my input prompt. I'm going to read in the input. Let's type in 150. So you can see again in memory, it's showing that the temperature value is now 150. It's evaluating the expression, checking to see if it's greater than 120. And that's true. It shows me that if I highlight, if I kind of mouse over it, it shows the value of the variable there. And then I continue to step through the code line by line. That sets the is safe value to be false. And as soon as I execute the instruction, pressing the down arrow, you'll see the is safe value over here on the right change to be false. So now is safe is false. It's checking the loop condition again. At this point, that loop condition is false and the program will continue on with its execution. So again, just like we could with the count controlled while loops, we can use the debugger with event controlled while loops to trace through our program for debugging purposes, to try to find logical errors, or just to better understand our code and how it responds to various input. Let's look at a second example. In this case, we want to continue to execute statements that print out kind of like a menu of options or something like that. And we want to continue printing the menu of options until the user selects no, they don't want to continue. So in this program, we're going to use a string entered by the user. I'm calling it user choice. And that is going to be the value that controls my while loop. So you can see down here where I wrote the while loop, I checked the value of user choice to see if it was equal to the character Y. And so I'm using that to control whether I want to keep going or stop. Above the while loop, I also have a statement that's prompting for input, and I'm reading the initial value of the user choice. This statement where I'm reading from standard input, that's the initialization step for my loop control variable. That's where I'm getting my initial value that tells me that I should or shouldn't start this while loop. Then the body of the while loop is inside the curly brackets. So it's everything here, all the print statements where it prints some stars and the word pretty and some more stars, and then asks the user, would you like to continue? Yes or no. And then finally reads a new value for the user's choice. This is the update step. And remember, you always have to update the value of the loop control variable inside the loop body so that eventually this loop control expression becomes false and the program stops. Let's type this one into IntelliJ. I'm just going to type over my old value. I'm going to delete my old loop and put a new one in here. Yeah, I'm using a string that I called user choice. And I'm going to prompt the user to enter the initial value for that expression. Continue, yes or no. Then let them enter their choice. I'm using the next method to read in a string from standard input. I'm going to check to see, well, the user's choice dot equals Y. And then I'm going to put all my print statements in here. I'm going to print out a couple of stars. And then I'm printing out the word pretty. And then I'm going to print some stars again. I'm going to add one more in here. I think that's right. Eyeballing it. That looks pretty good. And then finally, I'm going to ask them if they want to continue or stop. And that's the end of my while loop. Let's run it a couple times. So I'm just running it using the regular style of execution, not using the debugger. So it prompts me, would you like to continue? Yes or no? That's up here before the loop begins. So I'm going to press yes. So this is my first value for user choice. And then because user choice is a Y, I'm going to execute the whole body of the loop. And you can see it printed out all of those statements, the stars and pretty and more stars. And then ask me, would you like to continue? Yes or no. So if I type in yes again, then it is going to check to see if my input user choice is equal to Y. And because it is, it prints all those statements again. I can do that as many times as I want to print out the statements in the body of the loop. Eventually, I'll want to choose something that's not a capital Y. So I could follow instructions and press the uppercase N, that would cause it to stop. I can also press any other key here. For example, even if I press a lowercase y, it will stop executing because that is not equal to the capital Y. So remember, whenever you're making loops like this, where it's controlled by user input, it's really important to be precise with the capitalization and the format for the input that's requested to make sure that it's an exact match. Notice that if I run this loop again and I immediately pick no, so if when they initially ask me if I would like to continue, yes or no, if I type in something that's not a capital Y, the program will immediately terminate. And that's because it read my input, capital N, checked to see if that was equal to a Y. It is not, so it did not execute the loop at all and just continued on with the rest of the program where it closes the scanner. At this point, we've looked at some example programs using event-controlled while loops. Remember that event-controlled while loops always have three parts. They always have an initialization step where you initialize the value of the loop control variable before the loop test. Then you have to test the value of the loop control variable. And in my examples, that's been a single variable, but you can set it up so that it has multiple variables as well. Somewhere in the loop body, you need to update the value of the loop control variable so that eventually your loop control test becomes false.